Hello everyone. Today I'm going to show you how we can solve a 2D triangular element. So in this example we have 2D triangular and has also applied load on node number 3. So this is node number 3, and this is 1, and here is 2. Okay, and some details give me the elastic of steel and thickness and Poisson ratio, and ask me in this example to find displacement at node 3. So let's go to solve it. The first of all, we should start with to find the area of the shape. So here the area of the shape is, we have triangle, and the triangle is half base time high, but here is actually a different because we want to solve it by a matrix. So we will follow this rule: A equal half matrix 1 1 1 x1 x2 x3 y1 y2 and y3. So here we have x1 for the node 1 and x2 for the node 2, x3 for node 3, as same as with y direction. So let's go to substitute the values. Equal half 1 1 1, x1 is 0, x2 is 2, x3 is 1. So let's go to y direction. y1 is 0, y2 is 0, and y3 is 1.5. Okay, so the answer is, after you make this matrix is simple, you will get 1.5 meter square. This is the area. Then go to B matrix. B matrix is actually, we have a general rule for the B matrix. B equal dn1 over dx 0. Here is actually the nx, and here this is the ny. Okay. On ny is 0, and here dn1 over dy. That's mean the derivation for the element 1 actually is the derivation of n1 on the x direction, and here is the derivation of n1 for the y direction, and here we have dn1 over dy, dn1 over dx. This is for the node number 1. for the node number 2, we have dn 2 over dx, here 0, 0 dn 2 over dy, and then dn 2 over dy, dn 2 over dx. This is for the node 1, and this is for the node 2. Same thing with node number 3. So node number 3 is dn3 over dx. I'm sorry, I don't have enough space, so I will write here down. Here 0, 0 dn3 over dy, and the last one is dn3 over dy, dn3 over dx. This is our B matrix, because we need actually D and the area, and also sorry, here we found only B matrix, but then we will find for the D matrix also. So here actually this is the general equation of B matrix, okay, but there is some derivations depend on the criticals of shape function. You can go to any reference of finite element method, and you can know how can derive each one. So actually I can give you the last result of derivations, but actually go to critical of shape function and recheck again and follow the derivation step by step, and you will get these values that I will write it now. So for B matrix equal, actually to make it only a simple way, here it will be the first element 1 over x2 0 0, x3 minus x2 over x2 times y3, x3 minus x2 over y2 x2 times y3, and here is minus 1 over x2. This is for the node 1. For the node 2, 1 over x2 0 0 minus x3 over x2 y3 minus x3 over x2 y3, and here is 1 over x2. Then go to the node number 3, 0 0 0 1 over y3, 1 over y3, and 0. So we have this matrix for all elements we have, because here in this example actually we have 2D shape only, not 3D. 3D or the rectangular, it will be different way, a little bit, not but the same a little bit some procedure or characteristics, that's all. After that, substitute the value of x2, that's means for the x of node number 2, and here x for the node number 3, y for the node number 3, and x for the node number 2. Just substitute your values here, and you will get the final B matrix is actually it will be half 0 0 minus 0.33 minus 0.33 minus half. This is for the node number 1. Actually no need to draw this line, but just I want to show you, that's all, so I can delete it. And for the node number 2, half 0 0 minus 0.33 minus 0.33 half, and for the node number 3, 0 0 0 0.66 0.66 and 0. This is the B matrix. You can check the value after B. Maybe I have some mistake in calculate, or actually on the substitute values. So now go to D matrix. D matrix is E over 1 minus Poisson ratio small v, or some references they draw write it like mu, small mu, but it's up to you, depend on which the reference that you want to follow it. No problem. 1 minus 2 Roshan view, and we have a different value, I mean a different form for the D matrix. 1 minus Poisson ratio here, and 0. This matrix is 3 by 3. Okay, 3 by 3 this matrix. Then just substitute your values here. Actually we have for the E actually is equal as actually given in the question, 200 just time by 1 for the 6th power, and the Poisson ratio is 0.25. Yes, and that's all. Just substitute and you will find the D matrix. D matrix, it will be like this. This is the final value of D matrix. After that, you can multiply this matrix, all of elements of D matrix, multiply by B matrix, this one. Okay, then you will get the matrix of actually the matrix of multiplied by D matrix and B, because actually the general rule is K. I want to find the K matrix. K matrix is equal T time A inverse of B matrix, transfer or inverse, time D matrix time B matrix. So that I tell you in the previous slide, I say multiply D matrix with B matrix to make it easy, and just transfer this B matrix that you already got it, this one. Okay, for the A already we are calculated, and for the T is T, I give it for you, is equal, I think 50 millimeter. Just to put it in meter, it will be 0.05. okay, and the area already you will get it, it's equal 1.5, and just substitute your values and you will get the K matrix. K matrix, it will be actually a big K matrix. It will equal 6 by 6 elements. Okay, actually it's long, I can't write for you, I'll just give you the short solution for this problem. After that, you can go to F, matrix F, the force K time density, because I want to find the displacement at node number 3. So here for the F, we have F1, F2, F3, F4, F5, F6. Okay, and for the K matrix, K matrix is 6 by 6. So here this is the six by 6 for the K. Okay, and for displacement we have 6 displacements. Displacement 1, 2, 3, 4, 5, and 6. Okay, for the now actually go to the force. For the force, actually we have only one forces, only one force, because F1 is 0, F2 is 0, we don't have. Only F3 is equal 10 kilonewton if you go back to the first slide. Okay, and the other forces is 0, no need to calculate. Then I can divide the matrix for 4 parts like this to make it easy for solution. Here I will call it K11, K12, K13, K21 and K22. So this one K11, because I have here a value is 10 kilonewton, so this one K11 it will not equal 0, but the others elements I can neglect them, like K12 I don't need it, it will be 0. Okay, K21 same, it will be 0, and K22 it will be 0. No need to write a full calculation, because I have a 0 values of forces, and also for the displacement it will be equal 0, because the force is already 0. And for the displacement of number 1 equals 0, because as you see it's on the exactly on the cross area of x and y directions. So just find the displacement of node number 3. Actually I can give you and actually it's easy to calculate, just I can give you the key solution here. Equal 1 f1 f2 f3 equal 10. And the displacement we have 0. Only like this one, this K is K11 only, I take it. So the final result is displacement at node 2 equals 0, and displacement of node 3 equal 1.16 times 10 for power minus 6 meter. So that's all for the how we can solve or determine the displacement at any node for the 2D triangular elements. Thank you so much.